Next topic, states of matter. Matter around us exists in three physical states. We can see the matter around us either in solid state, liquid state, or in a gaseous state. So states of matter are of three types. First of all, properties of solids. Properties of solids. The first property of solids is solids have a definite shape. Solids have a definite shape. Solids, they have a definite shape and distinct boundaries, like a pen in your hand or a book. Like this pen will remain like this only. Its boundaries, they will remain like this only. It can't change its shape because the particles are not able to move here. So they do not change their shape when they are put in different containers. Whether I keep a pen here on this sheet or in a glass or in a beaker, its shape will remain the same. So solids, they have a definite shape because of distinct boundaries, and these boundaries will remain as it is because particles of solids, they are not able to move. However, there are some substances like sugar and salt, they take up the shape of the vessel in which they are placed, but yet they are considered as solids. Now, salt and sugar, if they will take up the shape of the container in which we are keeping them, then how come sugar and salt, they are considered to be solids? Answer is because the shape of the individual sugar, like this sugar particle, one particle, individual sugar or salt crystal, its shape will remain the fixed. Whether we take it in a hand, put it in a plate or in a jar. So if individual particles shape will remain the same, then this is considered as a solid. No matter, it will take up the shape of the container in which we are putting it. So the definite shape of solids is due to the particles which are there in this. Their packing is closed. Strong forces are there because of which the particles are not able to move. Hence, the solids, they have a definite shape. So in case of salt and sugar, since their individual particles, they will be of same shape whether we take it in a hand or whether we are taking it in a glass or in a jar. Hence we'll say sugar and salt, they are also solids. Second property of solids, solids are rigid. Solids are rigid. Solids have a tendency, they have a tendency to maintain their shape even when some outside force is applied. Like if I take this pen and start pulling it from here, its shape will remain the same. So solids have a tendency, this will have a tendency to maintain its shape even when some outside force is applied on it. They may break This pen can break when it is hammered or is dropped from the higher place. So solids are rigid. That means they have a tendency to maintain their shape even when some outside force is applied. But sometimes when they are hammered or dropped from the higher place, they can break. However, exceptions we have here also. However, some solids, they may change their shape under the influence of an external force. Like this pen, when we apply external force, it is retaining its shape. But if we take this rubber band and try to pull it, see, its shape is changing. But the moment I am removing this external force, it regains its shape. So there are some solids, however, some solids may change their shape. But when they will change their shape? Under the influence of an external force, but regain the shape. How they will regain their shape? When force is withdrawn. When we remove the force, then they will come back to their original shape. Example for this is a rubber band. Example is a rubber band. It changes its shape when we apply force onto this, but it regains its original shape once we withdraw this force. Third characteristic of solids. Solids have a definite volume. Solids have a definite volume. Volume means space. They have a definite space. That means they occupy a fixed space. Solids have a definite volume and they cannot be compressed. Solids we cannot compress. This is because of extremely small interparticle spaces in the solid particles. However, some solids can be compressed. Some solids, they can be compressed. For example, a sponge. Sponge can be compressed. Example, a sponge. It can be compressed. For example, this solid pen. It will occupy this much of space only. That is, its volume is definite. But there are some solids which can be compressed. For example, this sponge. This can be compressed. This is solid, but still this can be compressed. See the shape of this? Now, I can change the shape of this. I can change the shape of this sponge. But then why it is solid if we can change the volume of this sponge? A sponge is a solid which can be easily compressed. This is because in sponge there are small holes In sponge there are small holes, and what is there in small holes? The air is trapped in these holes. So when we press it, the air is expelled out and the sponge gets compressed. So this sponge is solid, but we can compress this. But this is because there are small holes in this. So when we are compressing it, the air which is there in these holes, that gets expelled. Next characteristic of solids. Solids do not possess the property of diffusion. Solids do not have the property of diffusion. Diffusion means mixing into other solids because of the small interparticle spaces between its particles. The interparticle spaces between the particles, the space which is there, this is called interparticle space. The interparticle spaces are very small in case of solids. And why these are small? Because these particles are very close, because there are very strong forces of attraction between these particles. So that is why the solids, they cannot mix up into each other. They are not getting the space to move inside each other. Because of these small interparticle spaces and strong forces between the particles of solid, they cannot move and hence they cannot diffuse into each other. However, we can observe diffusion of solids to a very limited extent. We can observe diffusion even in case of solids, though to a very limited extent. The example is, if we write something on a board with a chalk and leave it as such for 10 to 15 days, it becomes difficult to clean the blackboard. Why it is difficult to clean the blackboard? It's because the chalk particles slowly and slowly they are moved inside the blackboard. So when they move inside the blackboard, the chalk particles, when they move inside the chalkboard, that means they will diffuse into it. They will mix up into it. So when they go inside, it is very difficult to take it out to remove it. So even in case of solids, to some extent, to a very limited extent, diffusion is observed. So these are the properties of solids. Next, we are moving on to the properties of liquids. First property, liquids do not have a definite shape but have definite volume. Solids do not have a definite shape. Liquids do not have a definite shape but have definite volume. The volume is definite. Forces of attraction in particles of liquids, the forces of attraction are strong, but they are strong enough to hold them together. They will remain here only. So if the particles will remain here only, that means the shape of the liquid particles will remain the same. This shape will remain as it is because particles are held by the strong forces. Therefore, they have a definite volume. They have a definite volume. But these forces are not strong enough to keep the particles in fixed position. Therefore, liquids do not have a definite shape. Their shape will not be definite. For example, if we take the liquid, like for example, these are the particles of liquid. So particles are here and they are held by strong forces. They are held by the strong forces, but these forces are strong to keep them here only. So the volume of this film, the space occupied by liquid will be this much only. That means it will not change. So volume or the space occupied by the liquid will be definite. But since the forces are not strong enough to keep them at their position, they can move here at their position. They are moving here at their position. So when they can move at their position, that means like this. If I move a little bit these particles like this, the shape will not be same. The shape, see now the shape. The shape has changed now. So liquids do not have a definite shape because the particles are not there at the fixed position. They can move at their position, but they have a definite volume because forces are strong enough to keep the particles at their place. They can move at their place, but they cannot move away from their place. So we say liquids do not have a definite shape, but they have a definite volume. But to understand this thing, we have an activity after this. Experiment to demonstrate that liquids have a definite volume but no definite shape. For this activity, we are taking 3 containers of different shapes. One flask we are taking, one beaker we are taking, and one measuring flask. And in these we are pouring 50 ml of water. So after adding the 50 ml of water, we have to make a mark that till this 50 ml of water can be filled up. Till this. Even in this one we fill 50 ml of water and making a mark. Now we have to remove the water. Marks will remain there, but we will remove the water. Now transfer 50 ml of any other liquid into these containers one after the other. After water, now we are adding some other liquid. What will be our observations? First, we observe that all these liquids, they flow. Liquids flow, they move. Second, volume of all liquids remain the same. So after water, when we will add some other liquid into this, we will observe that liquid also 50 ml liquid we are adding, that also fills up till this mark. And even here also some other liquid when we add in place of water, that also fills up the container till this mark. Now even here that 50 ml another liquid will fill up the container till this mark. So volume of all liquid remain the same. So even we can transfer the liquid from this flask to this one, or from this one to this one. We'll see that 50 ml of the liquid, when transferred from one container to the another container, they fill up the same space. That means the volume of liquid remain the same. So all liquids, third observation, they take up the shape of the container in which they are put. Here the liquid will take the shape of this conical flask. Here the liquid will take the shape of the beaker, and in this case the liquid is taking the shape of measuring flask. So all liquids take up the shape of the container in which they are put. That means the shape of the liquid is not definite. It is not definite. This is the first property of liquids. Moving on to the next property of liquids. Liquids are not rigid but have a tendency to flow. Liquids are not rigid, but they have a tendency to move, they have a tendency to flow. The reason is the large spaces between the particles of liquid. Between the particles of liquid, there are large spaces, and forces of attraction between these particles, these are weak forces of attraction as compared to in solids. So because of these forces, the particles, they cannot remain here. The particle can break the force easily and can move. If the particle can move, that means liquids can flow. And because the particles are moving, that means the shape of the liquid is changing. So it is due to larger spaces between the liquid particles and weaker forces of attraction in liquid particles as compared to in solid particles. So the liquids can flow and can change their shape. Thus, liquids are not rigid. Liquids are not rigid. However, their relative fluidity differs from one liquid to the other. Example, water flows faster as compared to honey. So the rate of fluidity of the liquids is not same. Some liquids can flow faster as compared to the other. Liquids undergo diffusion, that is mixing. Mixing of liquids can take place. The reason is particles of a liquid can move easily. The particles, they can move easily, and the reason is because of the large interparticular spaces and the weak forces the particles are able to move. So in particles of one liquid, this is one liquid, this is another liquid. When the particles can move, they can move. That means they can mix up into each other. So particles of liquids move easily due to larger interparticular spaces in liquids. Therefore, solids, liquids and gases all can diffuse into liquids. Example, diffusion of solids into liquids. Mixing of solids into liquids. Like if we take water, that is liquid, and in this we add one small crystal of potassium permanganate, that one crystal of potassium permanganate, when we add into this, after some time we'll see the purple color is shooting into the water and whole of this water will become purple after some time. This is because the solid has moved into the spaces between the liquids. So diffusion of solid has taken place into the liquid. The reason is there are spaces present between the liquid particles to accommodate the other particles in them. So they are accommodating the other particles in these spaces. That is why diffusion of solid into liquid takes place. Next example is diffusion of liquids into liquids. Diffusion of liquids into liquids. When water is added to alcohol, this is supposed alcohol, and when water is added into this or vice versa, the two liquids quickly start moving into the spaces of each other. That is, they quickly diffuse into each other to form a solution. Now after the mixing of the two, what we get is a solution of water in alcohol, or we can say alcohol in water. Diffusion of gases into liquids. Some gases like oxygen, carbon dioxide, which are in air, they diffuse into the water. They start mixing up into the water that is dissolved in water. And these gases are required for the survival of aquatic animals and plants because they can diffuse into the water. So the animal and plants in water can take these gases for their survival. Now one note we have. Different liquids have different rates of diffusion. Different liquids have different rates of diffusion. Like ink can dissolve in water quickly as compared to honey. Honey will take some time to dissolve in water, while ink will dissolve in the water quickly. These are the properties of liquids. Now we are moving on to the properties of gases. First property of gases. Gases neither have definite shape nor definite volume. Their shape and volume is not fixed. Gases take the shape and the volume of the vessel in which they are placed. Gases, they take the shape and volume of vessel in which we are storing them. Example, inflate two balloons but of different shapes and sizes. Two balloons we have to inflate by blowing almost equal amount of air. But these two balloons should be of different shapes and sizes. So what we will observe? Air adopts the shape of the balloon in which it is filled. Like for example, we take one balloon of this shape and size, and another balloon we take, for example, of this shape and size of banana shape. This is oval shape, this is banana shape. Their sizes and shapes are different, but almost equal amount of air is blown inside these balloons. So if gas is transferred, they are taking up the shape of the balloons in which we have filled them. And if gas is transferred from one vessel to the another vessel, like gas is stored in this one, now we transfer this gas into a big vessel. The gas will occupy each and every corner of this vessel. So now this is the volume of the gas here. Same gas when transferred to the larger vessel, it will occupy the whole space of this vessel. That means gases will take up the shape and the volume of the vessel in which it is stored, because gases occupy the whole space provided to them. Second property of gases, gases have maximum fluidity. They can flow faster as compared to the liquids. The reason is because of the large interparticle spaces between the gas particles. The spaces between the gas particles are so large because the forces between them, they are very, very weak. Because of that, these forces can easily break. And these particles are free to move. Hence, gases have maximum fluidity. The third property of gases is gases are highly compressible. Gases are highly compressible. Again, the reason is the spaces between the gas particles, they are so large. So that is when we apply the pressure on these, they are coming close to each other because the force between these can be broken up easily. Suppose these are the particles of gases away from each other, and the force that is between these, that force is very, very weak force. This can be easily broken and the particles can easily move when we are applying the pressure on the two sides. So they're coming close because the space which is there is big, so they can easily come close to each other. So gases are highly compressible because of the large interparticular spaces between them. This means that gases can be easily compressed by applying the pressure. Example, LPG. Full form of LPG is liquefied petroleum gas that we use in our kitchens. Another example, CNG, full form compressed natural gas. This is used as fuel in vehicles. Both these are examples of compressed gases. We compress these gases to pack these in a small cylinder and tanks. Activity. To compare the compressibility of compressibility of solids, liquids and gases. For this we are taking 3 syringes and 50 ml syringes we are taking here, and we close their nozzles by the rubber corks. Syringes, and by rubber cork we are closing these syringes. These are the rubber corks. And the capacity of these syringes is 50 ml. Now we'll remove the piston. We remove the piston from these syringes. After removing the piston from these syringes, we'll fill the first syringe with the salt. Approximately 3/4 of the syringe we have to pack with the salt. In the second syringe we will add the water. In this we are adding the water. And then put the pistons back in the syringes by applying Vaseline. This piston here, piston is which can move inside and outside by applying pressure. So again we are putting the piston back here by applying Vaseline. Vaseline is used so that easily it can move inside and outside. So this is the position of the piston first of all. Three-fourths of the syringe packed with the salt, with water, and here we have not added anything, so there is air inside this syringe. Now put the pressure on these pistons. So when we put the pressure on the piston will start going inside. But in this case we see solids are not compressible. It's not possible to compress it. It will remain here only. But in these two cases, liquids are hardly compressible. It will go a little bit inside. They are hardly compressible. But gases are highly compressible, because when we put the pressure on this piston, it can go inside. So from this activity, what we will observe is, the observations are volume of salt. Volume of salt does not decrease. It does not decrease. While volume of water decrease marginally, very less. But volume of air decreases very significantly. This indicates that gases are highly compressible in comparison to solids and liquids. Fourth property of gases. Gases have low density. Gases have low density. Density is equal to mass upon volume. More is the mass of a thing in the per unit volume, more will be its density. So if we take, for example, 1 gram solid, 1 gram liquid and 1 gram gas. Let's say this much of space is occupied by the solid. Same solid we have taken, like for example there are 100 particles here. So they pack in this much of space. And 100 particles in this 1 gram liquid, when we change this to liquid state, 100 particles, they are occupying this much of space. While when they are in a gaseous state, they occupy, for example, this much of space, 100 particles. So 100 particles, when we'll take per unit volume, suppose this is your per unit volume, this much is your per unit volume, this much is your per unit volume. Here in per unit volume there are 100 particles. Let's say in this per unit volume, out of these 100 in the whole, for example, 40 particles are left here. And in this case, in this per unit volume, let's say 20 particles are left. So mass of 20 particles will be less as compared to 40 particles, and mass of these will be less as compared to 100 particles. Since the mass in per unit volume in gases is less, mass in per unit volume is less in gases. If mass is less, density of the gas will be less, because particles of gas, they are widely separated. They cannot pack very close to each other as compared to liquids and solids. Hence particles are away. When particles are away, in per unit volume less particles are there, so less mass is there. That is why density of gas is low as compared to liquids and solids. Next property of gases. Gases exert pressure. Gases exert pressure. Why gases are highly compressible? Because spaces between the particles are large. So when we apply the pressure on these particles, they come close. They come close because there is a space here for these particles to move. So gases, they exert pressure. Last property of gases is gases diffuse. They mix very rapidly. Why gases can move into each other easily? Because the particles are away, the forces of attraction between them, they are very weak. So the particles can easily move and can mix up into each other. That is why diffusion is very fast in the case of gases.